Let's get started. I want to kind of complete the topic we started last time about the automatic evaluation of text generation. And then I want to switch to a whole new topic today. Before we move forward, are there any questions about logistics? We are working on your last practical. Hopefully grading should be done in a week or so. And then the only remaining evaluation component is the final exam, which we scheduled on 12th of December, so somewhat late. So you are okay in this course. You can, I want to say, relax, but not at least there aren't any very, very hard deadlines yet. Yeah.
Maybe you've said this before, but will the final exam be comprehensive, or is it only going to cover material from the midterm onwards?
Yeah, I decided it's going to cover only midterm to the very last thing I ever say here. So only the second part. You all did relatively okay on the midterm. I didn't feel like there was something that I need to bring this. Okay. If you would like your notes from your midterm back, happy to give them to you as long as your name on your ID matches the name on the note. So let me know if you would like to have them back. Yeah, and then the final will be structured more or less like the midterm. You will also have opportunity to have notes on one page. So while you're studying, feel free to start sending things you feel might be useful. Yeah, any questions about any of that? We will talk about the final as the end of the course a little bit more, so don't worry. I would say I need to be cautious with what I'm saying. Like I want to say like, oh, chill, but don't be too relaxed, right? So continue coming to these lectures. I think that's helpful for the theoretical aspect, and yeah, continue studying. But yeah, we don't need to talk about it just yet. Okay, as I said like a week ago, because we had such a long build-up in this course, every single lecture will be important. There is no real like winding down in this course. So we are continuing with really, really important topics this week. And first, I'm going to finish about automatic evaluation. I won't repeat what kinds of evaluations we have learned last Monday. But remember, we have finished with embedding-based metrics, which basically took our generated summary of translation and our reference human written summary of translation, encoded both of these in some embeddings, and then we did some similarity with those embeddings to determine whether the generation is good or not. So the benefit of these metrics over our overlap or lexical-based metrics is that they are better at capturing more nuanced aspects of lexical semantics. So if we had in our reference and in our generation synonyms, we won't completely fail in saying that the generation is good, as we did with overlap-based metrics. However, they still have a lot of limitations. First of all, they don't measure something like factuality, right? Like you can have a summary that is sounding very alike your reference, but may make a factual mistake. And that would be, for example, for news applications, completely irresponsible. And I mean, many other medical summaries of clinical notes as well. Just one factual mistake can make the whole summary be completely flawed. And this is not something we would get from these embedding-based metrics. Similarly, more creative aspects won't be captured by these embedding-based metrics. We have computational costs associated with them because now we need to make a forward pass for every single reference and generation. And in case of BERT, to specialize our model for mimicking human judgments in application that we focused on, we also had to tune the model, which means we had to use some computation for backward pass. Also, at some point, we were talking about all the societal biases that are encoded in these representations. And this now can come back to us. For example, a summary or generation in general can be deemed more appropriate by embedding-based metrics just because it mentions some of these stereotypes. This can also lead to some mistakes out of these embedding-based metric. And then remember, our LMs were mostly trained on the internet data. So similarity of more general, broader layperson text is going to be better captured by these embeddings. But if we have similarity, let's say, of summary and reference for a very specialized domain, something like medical domain where we have a lot of technical terms, maybe they wouldn't do so well because they haven't seen this type of text. Although I said you can always specialize your language models to the domain using unlabeled data of the domain. So it's a problem that can be somewhat addressed, but it's something to consider. So now, it's an option, but we are still not happy with it. And this is what led the community to yet another automatic way of evaluating text generation. And this one is what most of us are using these days. And it's called LLM-as-a-judge. So if you remember how we use human annotators, we would basically use a language model in a similar way. So previously, I told you that we can use human annotators to basically do pairwise comparison or direct assessment. And in pairwise comparison, we would give to a person 2 generations and source text, and we would ask this person, hey, which one of these generations is better? And now we are going to task some language model with the very same task we have used before. For example, let me actually pull an example here. Yeah, this one. So this is an example how you would instruct your LLM to do a pairwise comparison. You would give it instructions such as, please act as an impartial judge and evaluate the quality of responses provided by 2 AI assistants to the user's question displayed below. You should choose the assistant that follows the user's instruction and answers the user's question better, and so on. At the end, you would give provide how do you expect the assistant to, the judge to give you the answer about which of the 2 options is better. You would then give the source in this example question and 2 answer options. So this is for judging when you have question answering task where answer itself is very, very long. And similarly here, instead of having a question, you can have either here is 2 summaries and you need to give in a source document. Instead of a question here, you need to, as a judge, determine which of the 2 summaries is better. Or if the task is machine translation, you would give a source text and ask which of these translations in target language is better. And we also, I said we can use people to give us direct assessment, right? Instead of comparing 2 generations, we said we can ask for direct assessment, and you can use a judge in a similar way. So you can instruct it, please act as an impartial judge and evaluate the quality of the response, provided blah, 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 be as objective as possible. After providing your explanation, please rate the response on a scale of 1 to 10 by strictly following this format. And again, here, the task is to assess the quality of an answer, long form answer for a question. You could use a source document and ask to rate the quality of a summary, or you could have given a source text and ask rate the quality of translation. One important note here is that for LLM-as-judge, we would typically use an LLM off the shelf. So you wouldn't do fine-tuning, meaning you wouldn't have labeled data and then change the parameters of the model. And one reasonable question you might have is how can the model judge so well and follow these instructions so well? And for that, we will need to have 2 stages of LLM development. We are going to learn about today and in the next lecture and probably a little bit more on next month. So for this, you would use language models that have gone through additional stages of development we are going to learn about very soon.
and you would just use them off the shelf. You wouldn't fine-tune them further for the judging task, although you could, and then probably would be better, but that means that you need to do fine-tuning, which very often you want to avoid for the evaluation purposes, just because it's more work, basically, and you need less data. There isn't anything inherently wrong with that. And as every automated metric, LLM-as-a-judge has its own issues. And here you need to deal with a lot of quirkiness that LLMs themselves exhibit. The first problem that LLMs exhibit is position bias. If you place if you give your options in a pairwise preference task in a given order, your LLM might just always or very often choose the first one because it has a bias toward picking the first option. And then if you had presented your options in a way that the better one, for which you know that it's better one, is always the first one, and your LLM has a bias to always pick the first option, it would seem like it's really correlated with human judgments, when in reality it's just choosing the first option. So what you need to do when you present these options for every pair, you need to shuffle them such that you break this cycle a little bit. There are also some other calibration methods. I'm here inviting you to check one of these papers. It's a super active area of research, so things are actively moving. I won't teach you any specific things for that reason. If you end up developing an LLM-as-a-judge, you will just consider all of these things and see what is the best right now. At some point, LLMs also preferred longer, more verbose responses. So they wouldn't choose the right, better option, just the one that's longer and more verbose, which is also not really what you would like. So maybe in your instruction, you can also say, longer responses are not always better. Here is an example of a shorter option that's actually better than the longer one. So sometimes you just need to be aware of these biases and then revise your instructions to be a step ahead and teach the model a little bit about what the model itself should consider when it's judging. It has also been shown that an LLM will prefer its own generations. So if you are using GPT-5 as a model that's creating your summaries, maybe don't use GPT-5 as a model that's also doing the judging. Mix these LLMs a little bit. Maybe use Claude or use an open source judge, okay? Otherwise, most likely your model would just choose whatever it itself had generated. And of course, if the model had a LLM has a limited capacity in certain domain, for example, we all know that very complicated mathematical reasoning is not something that current models excel. So if you want to use LLM to verify outputs itself can't really produce really well, it's going to be likely lead to poor judging. So there are certain places where you are like judging summarization. LLM-as-a-judge is pretty much standard today. Just verifying complicated reasoning is my mind. Yeah, you had a question?
Yeah, it's kind of random, but
yeah,
isn't OpenAI suing DeepSeek for doing like this task with ChatGPT?
They're suing them for something else, which very related, for using the outputs for training the model. But here you're not training the model. You can use outputs for evaluations. Yeah. Yeah. So we're going to touch on that, on synthetic data and issues in a few slides. Yeah. Also, somewhat of a digression. There's something called Chatbot Arena. I shared the link here. It is the go-to platform for evaluating new LLMs. So what you can do there, you can choose a battle mode and you can give yourself a prompt and you will get two outputs. You won't know which model produce which output, and you can rate which one you like better. Or you can say that both are terrible or they are equally good. And these ratings that people who actually submit things at Chatbot Arena are then used to create a score that you might be familiar from playing chess, so ELO scale. And this score is then used to rank models. And very often I will use this as a reference point to think like, okay, I need an open weight model, which one is the best according to this arena to choose one, because they are, you know, constantly being released and I can't keep track of. I do want to mention this recent paper called The Leaderboard Illusion that is talking about how this chatbot arena can still be gamified. Because in theory, these prompts should just come out of public and we should get these outputs and we make impartial judgment because we don't know the sources of models. So in that way, it's an impartial judgment of current models, also for things that people care about, right? Like the idea is that you would come to this chatbot arena if you have certain instruction, you are excited to see whether newest, latest model should do. And in this paper, they discuss how actually the creators of Chatbot Arena that gives some private early access to some of the companies that can then use to basically overfit on this arena. So, you know, as every evaluation in machine learning, it comes with its own set of issues. But yeah, basically this LLM as a judge is a core component of this Chatbot Arena as well. All right, so one thing I keep saying is, all right, we have these automatic methods, and then our human judgments are our gold standard, and I kind of in passing was saying they correlate or not correlate with human judgments. And I want to specify what do I mean by that. So basically, whenever you create a new automated metric, and these days, any version of LLM as a judge is deemed as a new evaluation metric because maybe it hasn't been tested on your specific problem. It might have been tested on some other data, and these authors have found success by using LLM as judge. You cannot just assume because it worked for their judging their outputs is going to work for your outputs. So today, when you are using any automated metric that wasn't tested before, you are going to calculate person correlation between the scores obtained with your metric and human judgments. And here I'm referring to the scenario where we ask both the person and the automated metric to just give us a score for not pairwise preference, although this is easy to extend to the preferences. So here I'm giving you some totally made up mock data just to illustrate how human judgments and some automated scores can be not correlated, right? Like if you pay attention here, you will see, okay, we have 0.62 for 5, and then really low for 4, which is just one score lower in human judgment. And then later if we see score 1, which would mean by this made up data, this is really bad. Output had given by this score, made up score, it's 0.68. So this is an example where human quality judgments and scores have nothing to do with each other, as an example. So in reality, when you are trying to see whether your automated scores and human judgments are correlated, basically you create a data structure like this, right? Like whatever data structure you like, but let's say we chose an array where we keep list of human scores and a list of automated scores in the same order for the same outputs. And then you just use CPy or whatever you like to measure the correlation between these two arrays. And if you have very high or moderate correlation, you would say, well, my automated score are moderately to highly correlated with automatic measure, and that's good enough for intermediate development. So I can, tweak hyperparameters. I can do all the things I usually do when I develop a machine learning model. But your final evaluation still needs to be human evaluation, meaning you would still do a pass where you recruit some annotators who then judge your final outcomes, because people are so hesitant to believe any of these automatic metrics that human evaluation in the end is truly important, assuming you have trustworthy annotators. I would say it's really hard to find trustworthy annotators today, as LLMs are becoming better. We, in my research group and in many other research groups, have noticed the issue of annotators themselves using LLMs, which completely beats the point of, showing what a person would deem a user of an application about our outputs, right? So it's really, really challenging. But still, we kind of expect that researchers give their best effort into recruiting real trustworthy annotators and showing what the human judgment would be. So just as an example of this mismatch about human and automated metrics, here I'm presenting you tables from one specific paper. And I isolated it because I know they have shown how you can have different insights about the summarization model depending on which metric of evaluation you use. So these are the results when we use human evaluation. Here, basically what we are seeing here is results where human annotators were presented with outputs out of 3 models, something called Rio, T0, and GPT-3, which were state-of-the-art summarization models at the time. And then they report a fraction of times each one of these systems outputs was reported as best when these 3 outputs were given. 3 outputs meaning 1 from Brio, 1 from T0, 1 from GPT-3. And what you can see is that very often GPT-3's outputs were chosen as the best among these 3 by human annotators. However, when we look at the table where they reported automated metrics for this system, so here you have Brio, T0, and GPT-3 together with one additional baseline that they excluded from human annotation. You have various data sets, and then you have various metrics, some of which I taught you, some of which I didn't. So we have our overlap-based metrics like Rouge and Blue you learned about, and we have similarity based such as BERT score that I taught you. And what I want you to notice here is that where the green row is, that's very often associated with the Brio model, right? So according to automated metrics, Brio's outputs are the best, and GPT-3's are at least in 3 out of these 4 data sets being the worst, according to these automated metrics, where human evaluation showed us that GPT-3's outputs are actually the best. And this is an example of how automated metrics and human judgments can be completely mismatched. And as I said, human judgments in the end are our holy grail, because in the end, it is people who use these systems and who care about how they perceive these outputs. So I can tell you that when I write papers today, when I read papers today, I almost never care about any of these evaluation metrics. You have to learn them. You have to know what Rouge and Blue and BERT score are. But these metrics have repeatedly been shown to be not correlated with human judgments. And knowing that, you just can't trust that the best system according to these metrics is truly the best system. So what do we usually use these metrics for today? In papers, at least, it's we run them and report them in the appendix, and they are a great way for people to do reproducibility study, right? Like if they want to see whether they can get the exact same outputs as I did, they should get roughly similar scores here. So it's good for reproducibility. And also, like if you are interested, you can still use, for example, Rouge and Blue, not as a measure of like quality, overall quality of comparison with other systems. You can use it to interpret what you know about those metrics. So you know that Blue tells you the precision of your n-grams relative to some specific human written reference, and Rouge tells you about recall, right? So if you notice really low recall, you wouldn't maybe necessarily conclude, well, my system is terrible, because you still know you could phrase your summary completely differently and still achieve good summary. It's just very different from human reference. But then you know, okay, why did my model choose such a different phrasing from this human reference? And that could be a point for additional analysis or inspection. So the point I want to make here is don't use these metrics as the final evaluation of the quality of your system, or to say your system is better than some other text generation system, but they still have useful settings. For example, for reproducibility reasons, or for kind of, if you think there is something buggy going on with your model, you can see, oh, do you get incredibly low rouge? Maybe that kind of hints that there is something really wrong going on, and you can inspect. Okay, so now here I am sharing a Colab notebook where, if you'd like, up to your discretion, this is absolutely not graded, and by completing this, you will not earn any extra points. But if you feel so, there are, this is an empty, empty in the sense I'm not giving you a solution, but if you would like to practice how to use these automated metrics and how to go about evaluating LLM as a judge, you can work on this. And if you do, feel free to send me your solution, and I'm happy to check it out. But this is completely up to your discretion. It's much simpler than your usual assignments. So it's definitely not as deep or broad. It's mostly, okay, there are these different packages for using rouge, blue, bird score, like making sense of their documentation on how to use them. And also I've given you a specific real data set for measuring the quality of summaries. So you can kind of also get a little bit more accustomed to the data format, and also to measuring correlation, inspecting correlations and things like that. But again, completely up to your discretion. Don't quote me on you worked on this and lost time and now I'm not grading. Okay, and I want to finish quickly on a few notes about summarization and evaluation before we completely shift gears. So one important aspect of text generation is factuality, right? I have told you before that hallucinations, making up facts that contradict the real world or something that doesn't exist in the real world, is an issue that LLMs exhibit. And depending on application, this can be a huge issue. So researchers are quite excited about measuring factuality. And again, we could recruit some annotators, and we could tell them, find the source text and check whether this is factually correct or not. But again, as always, we have an issue of recruiting trustworthy annotators, and then resource, like being able to pay them and have a large-scale analysis. So people are really excited to do this automatically. And I would say among the first notable automated metrics for measuring factuality in generation is fact score. There are many more advances over fact score, but it kind of initiated, I would say, this line of work. So it's worth knowing about. And basically how they go about is you have the summary, you break it in some atomic facts, and then you verify this atomic facts with respect to some resource and aggregate these results. And here they focused on something really narrow, just the biography of famous people. So they could use Wikipedia articles of those people to verify, let's say, each sentence or less in a generated summary with respect to this Wikipedia article. Obvious issue is how to scale that, right? Like how, if I have something way more out there, what is my replacement of Wikipedia? And I didn't say here, but an LLM itself is breaking the summary into atomic facts, right? So in a more complicated text, knowing what a reasonable atomic fact could be, such as this person is American or is an actress or is a model, what is that for other domains becomes more challenging. So yeah, just know about fact score, know that there are many more new advances over fact score, and it definitely isn't a solved problem. And the last slide I want to mention on like new areas of summarization research. So I mentioned people are quite interested in generated factual summaries, especially if the input is really long or the summary should be longer. And measuring factuality automatically is also an active area of research. Here, another active area of research is what if our input is incredibly long and we need to summarize it? So what about summarization of a book, right? And here in this table, it is probably outdated now, but every row is different aspects of the quality of summarization. And this is done purely with human annotators. So we have chronology, omissions, factuality, overemphasis, and so on. These are all aspects of summary we would not like to see. So lower is better here. And then we have positive metrics like comprehensive and well done. And in April 2024, so last year, LLMs, which were the best LLMs at the time, contained factual errors in over 58% of their book summary. So as you can see, that at the time, this was a massive issue. I tried to find, so replicating a study like this is hard because you need human annotators who can actually judge the quality of a summary in a context of a book. So that's quite intense, and knowing where this paper came from, this kind of budget is not available to many. I couldn't really find what is the state of this today. I did find two related evaluations that I want to show you. So one of them is, both of them are not about summarization, rather they are about answering questions in the context of long text. And these two things are often, there is a connection. If you can answer questions from a very long text, well, then likely your model also has skills to do summarization in the context of the long text as well. So here, this benchmark has as inputs very, very long inputs, and question is about figuring out this very, very long text, like recently published novels. And you can see that GPT-5 from August this year has an accuracy that doesn't exceed 70%. So that's pretty low, right? And similarly here, there is another benchmark for long context LLMs where we have multiple DocQA. They don't have quite GPT-5, but you can see very, these proprietary big models. And you can also see that the overall performance, if 100 is the upper bound, isn't so great. So I can't tell you a lot about these works. I'm not so familiar with them. They come from very respectable groups, so I trust these results. The bigger point here I want to make is that when your input is really long, doing this classical NLP task like question answering and summarization is struggle. Although summarization and question answering in the context of shorter text is someone would even dare to say solved task. Today, I would say that depends on the domain itself. Like if I'm having questions about some, I don't know, compiler text, Intel documentation, that might, although the snippet itself might not be super long, might be still very challenging. So yeah, but in general, the longer the text is, regardless of the domain, it's going to be high. Okay, so this is as much as I want to say about summarization, question answering as applications and how to go about evaluating them. Are there any questions? We are going to make mega pivot now. So if you have questions about these applications, now is a good time. I mean, any time is good. You can always ask me questions, of course. Yeah.
So I didn't confused about the difference between like the foundation model and then all these tasks we pre-trained or fine-tuned for. Because like we've said multiple times, like something like ChatGPT is really good at all of these things. Like, or is the team fine-tuning in a bunch of different settings and then releasing like that final model with then fine tuned as much. So I feel like fine tune on specific tasks can make it worse at different ones.
Yeah, so first of all, we haven't talked about LLMs like ChatGPT, right? Like we are missing some, and that's basically what we're going to talk about today, Wednesday, Monday. So I think your question will be much clearer to you after today's lecture. So let's wait on it for a second because we are going to see how it can require all these skills. But I do want to acknowledge that what this phenomenon you are mentioning, forgetting about certain things, this is called catastrophic forget. And that has still become an issue. And when I'm by the end of today's lecture, remind me of this. There is something I want to say. It relates to today, very last stage of post-training. It's going to be specialized for mathematical reasoning. And the reason is that if we have done this before, we wouldn't forget that. So because this is the hottest area of development now, everyone is doing it as a final stage to have the least forgetting for that particular skill. Although we might be forgetting some other, but that one isn't at the center of the current hype. Let's put it like that. Yeah. Joseph, you had a question?
Yeah, are there other benchmarks? You showed 2 benchmarks online. Are
Yeah.
there many other benchmarks for assessing LLMs in general?
For LLMs in general, yeah, there are so many benchmarks. So I mean, I would say thousands of them. So the best place in general, if you need some benchmark for something specific, start with your search, just a regular literature review. You search Google, you search Scholar, Semantic Scholar, and so on. But a bunch of benchmarks are going to be in Hugging Face's datasets. So you will find them there. It's just that it's a little bit hard to search here, long, context generation. It's not designed to be something like search engine. So it's going to be hard to just write your free-form queries here. But if you are kind of having like a sense of what the keywords can be, you will start seeing data sets here, right? So here I have put long context, and there are already 92 data sets in Hugging Face that contain long context in their title. So you have so many benchmarks. The question is, what is the right benchmark, right? And this basically requires you to literature review to see what is the one that people use in the field. Yeah. Yeah, and kind of the reason for why there are so many is because we use LLMs for so many different things, right? So hence so many. Okay, so I'm gonna now shift into a whole other topic. So if you remember weeks back, I said, well, we still have to learn certain things to understand what LLMs like ChatGPT or Claude are. But I felt the course turned a little bit too machine learning, and I wanted to take a step and go into applications like question answering and summarization and evaluation of text generation, where is more central to the NLP itself. So now we are going basically back to when we learned about pre-training and fine-tuning and different transformer architecture, and specifically decoder only and language modeling as pre-training objective. And in the past weeks, when we were talking about applications, we focused on this paradigm where we take a pre-trained language model and then we fine-tune it with our label data. And now we are going to talk about 2 other now and in a few more lectures about few additional steps that had happened after pre-training that give us a model that all of us use for various purposes. Okay, and one of the things that's also going to change is this fine-tuning state. We're slowly going to let it go. But I want to say, although we are going to learn about approaches that don't require fine-tuning, It does not mean that you should never use fine tuning. Rather, you should know when to use fine tuning and when not. And I'm going to come to, once we are done with these 2 extra stages, let's say Monday, Wednesday next week, I'm going to kind of go over what I think when you should use fine tuning and when you should not. Okay, so let's start with this motivation. We have some layperson or domain expert, like a legal professional clinician, and they are interacting with an NLP model. But unlike all of you, they don't maybe have access to model parameters or weights, or unlike you, they might not have knowledge about what to do with that, right? Like now, after this course, you know, well, if I have a pre-trained language model and I have access to models and weights, I can go to Hugging Face, find the appropriate code skeleton to start fine-tuning this model with label data that I am assuming you have access to. However, in this situation, this person has no access to model weights, doesn't know what to do with the weights, even if they have it, but they're able to provide a few examples of what they would like the model to do to the model. So we wanted to provide useful language technology to these people as well. And this goal has become really popular in 2022 with the release of GPT-3. GPT-3 came with the release of a playground, something that looks very alike chat interface today. And we all went crazy and submitted all sorts of things over there. However, in 2020, has any of you interacted with GPT-3 in 2020? Interesting. No. Ooh. Well, then you need to trust me that it was really bad. Like it was really, really bad. And but it was much better than everything else at the same time. So it was like this weird thing where you had like, oh my God, you can do a bunch of these things. We just without, you know, using this additional linguistic structure stuff I didn't sure about. So in that sense, it was really impressive, but at the same time, like if you had any instruction you put into ChatGPT today, it would be really bad. So together with GPT-3, prompt engineering emerged. And how many of you have heard about prompt engineering? Yeah, like a lot of you, right? This refers to the process where we are iteratively changing the way we ask the chatbot for information we need, because we understand that during this pre-training, it has required a bunch of this broad knowledge. It's just a matter of how do we extract that knowledge from the LLM? Like what kind of language LLM needs for it to give us the answer? And very often, after a lot of iterating, we realize actually it can give me the thing I need, but I just needed to find this quirky way of asking it for information. There are so many strategies for prompting. There is this very comprehensive survey called the prompt report that I encourage you to check. What is a prompt in itself is it's an overloaded term, and there isn't like a specific definition for prompt. I would say it is something we give as a starting input to our model, and it can contain the following information, but it does not need to contain all of this information. So very often it's going to start with a directive. It's going to start with an instruction or a question, such as tell me 5 good books to read. And then very quickly, we have realized that if we give few examples, it's going to be better at the task. So when you give few examples, we also refer to these as demonstrations. You want to specify output formatting, because if the model has a lot of options for how to present its solution, it's going to be hard for you to programmatically extract the answer portion. So sometimes the model may say the answer is, or so the answer is, or answer column, or I choose option, you know, like there are so many different ways. And then for you to actually understand which part of this response is the actual answer that you extract and use for your automatic metrics becomes more challenging. So you might want to specify output. For example, in my research group, it seems like JSON outputs are the what everyone likes. So you say, okay, which parts of the JSON the model is going to use for what. And then we have the last two are definitely not necessary. But what people have also observed early on, is first of all, you very often have additional specifications for stuff. So for example, if I use LLMs, I'm almost always saying respond concise, right? Like I want concise answers. So you might add some style instructions. But what I actually wanted to say is that early on, we figured that if you start models to pay a certain persona, they tend to give better response. So here is a funny example, pretend you are shepherd and tell me about something, but more often it's, for example, I'm going to refer to this legal benchmark we have created recently. And maybe when we create a judge, we would say, okay, you are an expert legal professional in a very reputable firm and so on. And it helps for some reason that if you take my interpretability course, you can answer for me. This is a screenshot from that prompt survey paper. And as you can see, first of all, I didn't fit the whole taxonomy. The first reaction for you can be, oh my God, there are so many prompting strategies, and there are, right. I don't want to teach you every single one thing that's here, of course, but I do want to cover these three first categories. And I wanted you to know what these first three categories, zero shot, few shot, and thought generation mean. Those are the important one and will be for sure your option at some point. So let's start with a first type. So here, I'm going to give you how we created a prompt for getting answers in our reading comprehension dataset, which was targeting whether the model understands negation. So we started with instruction. In this task, we are expected to write answers to questions involving reasoning about negation. The answers to the question should be yes, no, don't know, or a phrase in a passage. Questions can have only one correct answer. Although I'm going to build up this prompt, keep in mind that this is just a single string. It's not like multiple separate strings. Then you need to give an actual instance that the model needs to solve. So here for us, it was a passage and a question because we wanted the model to answer the question in the context of the passage. And we would finish with this answer column such that we kind of implies now is your time to just give the answer. Don't talk more. And then this is our one string that's input to a model like decoder-only transformers such as GPT-5 or Llama. And now you all are pretty, I think, solid on next token generation. So you know, okay, we have put this in a decoder model to get all the vectors such that we can use causal attention. And now this, let's say, answer column is just one individual token. Now we are building just yet another stack of representation. And at the final representation, the final layer, we are using the language modeling head to calculate distribution over the vocab. And then in this case, we would actually use greedy decoding because creativity is not necessary here. We are not creating long text. We just want yes, no, don't know, right? So we don't need to sample out of the distribution. Okay, and this is called, first of all, this is an example of a prompt, but it is an example of so-called zero-shot prompt or zero-shot. I'll use the word learning, although there is no learning here because we're not changing parameters. And this is basically how you use ChatGPT, right? Like you're very rarely giving examples, you're just giving instruction, and here is a question or whatever that the model needs to solve. So it's called zero shot because zero training examples are used. So I will repeat this approach where you have prompt input like task, instruction, and evaluation example, and you just ask for the output and there is no further training, so no changing of model weights. This is called zero shot prompting. Okay, there's a little caveat here, and that's that you must be sure that your evaluation example isn't part of the pre-training data. And today that's really hard to ensure. But if you have certain phenomena you're checking and you have lots of examples and you see that in general the model is pathetic at it, then you can't know, okay, it's probably you don't have pre-training data containing your evaluation instances. In general, zero-shot learning is a machine learning framework where a model needs to make accurate predictions for a given task without any number of labeled instances for that specific task. It had rich history before prompting and large language models, and it typically involved that, you know, this new label for which you didn't have training examples, the models could still make sense of what to do for that new class from classes it has seen during training, and there were various algorithmic approaches to that. Okay, so here, I just want to show you, okay, I prepared a little notebook where, oh no, okay. Let me see what it did. Basically here, I have 3 parts. One is to fine-tune a model. Then there is for zero-shot prompting and then other ways of prompting it. So let me actually scroll through this and let me make it larger. Okay, so here I chose FLAN-T5. For now, I don't want to explain why this model, but in a few slides, I will explain why this model was chosen here. And let's just go over a few bits of how you need to prepare your data. So here I'm using SFT2 dataset, which is the binary sentiment classification dataset. And this is the one you have used in your first and second homework, and third one, I guess. No, not third one. Third one was about language modeling. I mean, fourth one was about language modeling. Third one was BP. So in the first 2 assignments, you have tried to do sentiment classification, right? And this is something we have briefly mentioned before, but when we approach classification and other discriminative tasks as a text generation, we need to transform the label, which is 0 or 1 in the data set, into something more natural languages, such as positive or negative, right? Again, this is an example of how to use auto classes. So remember, every language model had its own tokenizer, and you cannot use other tokenizer because then there is a mismatch between the vocab and the token embedded, right? So you need to always use tokenizer that comes with the language model itself. And to not care where is this tokenizer or what is it, you just use auto tokenizer in Hugging Face, and by giving the right model name, is going to use the right tokenizer for you using this function from pre-trained. Okay, so this is this bit where I mentioned if we are approaching the discriminative task as sequence generation, then we need to turn our integers for classes 1 or 0 into things like positive and negative, because we are teaching the model to give us these labels. Okay, so this is a little bit piece of code for doing that. And now here, if we were to do fine-tuning, you are giving you how you feel about this. We have seen this previously. We would here use, instead of auto model for sequence classification, we would use auto model for sequence to sequence LM, because we are generating a label. Again, you don't need to care about where is the code for using for doing next token prediction with for this specific model. You just use auto classes, and Hugging Face takes care of everything for you. We have seen previously training arguments. I don't know what's going on here around this just before the class. So there are some bugs, probably because Hugging Face had changed something by upgrading the library. One additional thing when you give to your trainer is a metric use for evaluation set. And here you need to kind of remember that you have changed things into strings. So you need to now be checking that you're matching strings rather than integers. So just a little bit of pre-processing, nothing special. And then you use sequence to sequence trainer, you give all your training arguments and other stuff, and all you need to do to actually train this, fine-tune this model is trainer.train. So this is a classic standard way of using Hugging Face to fine-tune a model. And here specifically for classification task by using sequence to sequence approach where we generate the label. What I actually want to now dig into is how to do prompting here. And first of all, you would create your tokenizer and model the same way you did for fine tuning. You load everything from pre-train. This loads your weights. It loads the right tokenizer. And then let's go into this one. So here I'm just going to show you an example for one sentence. I randomly pick a sentence and I'm going to craft my prompt by saying review column sentence. And then in a new line, is this movie review sentence negative or positive? The answer is. This is an example of how to create a prompt, right? And as always, I need to tokenize my inputs, which is now my prompt. And given those inputs, I want to generate the outputs and show what the predicted label is and what the gold label was. Let's see whether this is going to work because there were errors before. Okay, there are some kind of errors here. Okay, because there were errors before, it seems like the sequence of cells isn't run properly. So it thinks that we didn't create model checkpoint. Let me try one more. I don't want to spend too much time if this is buggy. But, you know, the only important thing here to know is that we created a prompt, which in itself is just a string. We had here variable sentence, but it's replaced by actual content of that sentence. As we had used models before, we just tokenize it, give it to the model, it generates something, and that's our outcome. Okay, it seems like it's too buggy. Let me... All right, let me see whether I can do anything here. I'm just going to refresh the whole thing. Okay, this is the last try. I know I said previously last try, but okay, it won't work today. But in any case, this is just what I wanted to show. You create prompt and give it to your model. For me, what I have noticed previously, I don't know why, maybe because my slides were building up the prompt from various texts, and there was a confusion as if we are creating 3 different strings. Please just pay attention here. I have created just a single string for my instance. Okay, now moving on to other kinds of prompting. One super important way of prompting is called in-context learning. Learning is a little bit imprecise here, and I will say in a moment why. So the only thing that changes with in-context learning is that we give, together with task instruction, an example we want the answer for. We give some demonstrations, some instances where we have input and actual desirable output for those instances. Actually, it's here. So this is my extension of my previous prompt where I just added in sandwich between my instruction and my evaluation instance for which I don't know the answer. I have put a few examples. So the key difference between this one for which we don't have the answer is that here I do have the answer, right? So I'm showing the model what do I want it to do. So I'm showing it an example of a passage and right answer. And this gives an opportunity to the model to both understand, I just want the answer here. And also, okay, you can see how I reasoned about this problem from few previous instances. Typically here, you are limited by what you can fit in these contexts, but remember that the input context length now is pretty large, right? Previously might have been only 512, so you couldn't fit as many demonstrations as you wanted. These days you can fit without a problem 16 demonstrations, and this is something we would typically see 16 or If you really want to give a lot, maybe like 32. Okay, so in context learning is a type of prompting where we give a few demonstrations in the input. And again, because this is prompting, there is no further training or changing of model weights. And this is an instance of so-called few-shot learning. So previously I told you zero-shot learning is a machine learning framework where the model needs to make predictions for things they haven't seen during training. Here, the model has actually seen the instances of a problem, but very few of them. Okay, and finally, now that the notebook is broken, I don't want to go back to it, but I have when you go home, you can skip the fine-tuning part because I think that's what causes the call-out to crash. But you can go and check how I constructed the prompt with few examples. Yeah.
I think the bug is that there's an argument that just needs to be changed to eval instead of evaluation.
Sure, but the fine-tuning part is going to take a long time to even actually start. So the right thing here is to actually rerun the data part and then go to the zero shot directly, which I think we have too little time for that right now. Yeah.
Did you add new lines in the prompt? You put the escape to new line or /n?
Yeah, you do. Again, this is a choice. It is very typically done. So I would add it, but you don't really need. Yeah. So again, there is it's a choice I made for my prompt. Whether this is a great choice for your prompt, no one can tell you without actually trying things out. Yeah.
Is that the same with the pound signs?
Yeah. Every single thing that's there is a choice. It's not a recipe. Not every prompt needs to have anything that I use. Yeah. It's one example of one way to do a prompt. Yeah. Yeah.
Are there certain components of a prompt, like the output formatting, style instructions, that sort of stuff, that is inferred by a model when a prompt is given? As in, if they aren't specified, then there's sort of a default that is assumed?
Yeah, so there is something called system prompt, and it's the very first part of, let's say, a dialogue. And there maybe the creators of the chatbot will write something which would induce default behaviors. For example, we don't know what system prompts of ChatGPT are. So OpenAI developers have their own system prompts. And although you think that the first thing you wrote in ChatGPT is the very first thing in the subsequent string, actually there is something that they are going to prepare to the beginning. So this is why you see these differences between GPT-5 and 4.0 having slightly different style that people have been really upset about. So the GPT-4 was a little bit friendlier, and GPT-5 became a little bit, since I'm Eastern European, I'll say Eastern European, a little bit more direct. Like just a little bit, yeah. And apparently that was a big problem, which is a lesson for me to learn as well. Yeah, so there might be some defaults, but we wouldn't really know which ones with proprietary models. Yeah. The last example of prompting I want to teach you is this idea of adding let's think step by step. So people have noticed that you can add let's think step by step, and if you're using few-shot learning or in-context learning, you would also then give an explanation for the answers before you give the answer. So here, this string, I won't read it because these problems are honestly a little bit hard, but basically it explains why the answer is no for this problem. When you add, let's think step by step, this is generally today called chain of thought prompting. And what the model is then expected to produce is explanation, reason for its output together, so the answer is, and then answer. And this has been taken to a whole new level in the last year. People have noticed that for reasoning models for reasoning tasks that require more reasoning, like more complex mathematical problems or more complex coding. If you give model option to right here, it will eventually kind of come to the answer. And this is now called test time compute. Just how much compute you give to the model to generate these tokens at the inference time, because there is correlation between generating more tokens leading to the answer for a more complex task. And then another kind of line of work emerged from that. People are like, okay, you know, having all these extra tokens is beneficial for the model. Let's have another post-training stage where we train models to actually do that. And that's kind of hot right now, and it leads to something called reasoning language models. So if you're taking Kenny's agent task course, I think he'll teach you about that a bit more. So in my group, for example, we are looking into when models verbalize these things, whether they are actually accurate relative to their internal computations. It's a really hard problem because we don't really know what's going on in internals, but there is evidence, and we have methods to show that models can verbalize something, but then internally use something completely different, which can lead to issues like over-reliance and you know, doing, I would say, a little bit dubious science, because you think, okay, this trace is an evidence that my model knows so and so, when in reality your model is like randomly sampling digits or something like that. So yeah, chain of thought prompting, 2022. So we are approaching more recent history. It has been shown to induce this verbalization of reasoning. Whether it's faithful or not, it's an open research question, right? Very often we have seen it's not. So it gives us these traces. I keep saying, you know, I want to say something nice and then I trace back and say something wrong. But anyway, they kind of induce this justification of the problem. And it has been shown that it is beneficial for this reasoning task that require more computation. Okay, so now we have seen zero-shot prompting, in-context learning, and chain of thought prompting. Those are those three main categories, but there are many, many more. What I want to turn to is that what I said, that the 2020 models could not follow these instructions very well. So what has happened, right? Like your experience probably doesn't match this sentence over here. And what has happened is a new stage of development of LLMs. So what you learned from me so far is that we take our, let's say, decoder-only model, language modeling or next token prediction as a pre-training objective, very large-scale data, mostly coming from the internet, and we train the model to predict next token. However, in 2022, after this stage, very often, and these days always, when a company is developing a new model, they're going to do so-called instruction fine-tuning stage. And this stage is because now we know that fine-tuning is nothing less than taking labeled data and continue training the model on that data. You probably are thinking, okay, this is just supervised training, and you would be right? So here we are taking bunch of pairs of some prompt instruction together with a desirable response. And we are fine-tuning the model. And again, we are using language modeling or next token prediction, but now we are going to try to generate desirable response, which is not just randomly found on the internet, right? So if I have, for example, prompt, please summarize this text as an expert legal professional, and I give some contract, let's say, and then some legal professional have written desirable outcome here. This is not something I just found anywhere, right? Like this is much more high quality data than we find in pre-training, where you just have scrape text and just do completion of text, right? So this data will be massively smaller than the pre-training data, and actually something you could if you really want to do at CHPC, like you have to do that. Yeah.
So does this demonstration data come from when ChatGPT says a D preferred is output A or B? Is it that data from previous?
Yeah, if you do give that response to ChatGPT, yes, that basically are giving data to OpenAI. And in this way, they can use whatever response you actually liked as a like a response that's desirable because some person has said this is a desirable response. But it's actually generated, right? So this is not human written data, it is synthetic data evaluated by some person. Yeah, and we'll come to the synthetic data in a bit. Yeah.
So is all of this demonstration data previously generated by LLMs, or is it a mix of like some domain expert?
Yeah, we'll come to that. So just a second. Okay, so let's repeat what I just said. First of all, instruction fine-tuning or supervised fine-tuning or SFT, this abbreviation, I will never give you abbreviation unless they are important. So SFT is something people will refer to commonly. It is another training stage of language models. And now we refer to these training stages as post-training, right? So we have pre-training and we have post-training, and if you want to, later you can still have your own fine-tune. And very often we don't do this, although this is something we could do. This is something that companies that did pre-training will also do, and we'll just reap the benefits. In any case, let's say that the companies do this. So they start with the pre-trained LLM, and henceforth we are going to refer to this as a base model. And very often with the names of models that are available on Hugging Face, you will at the end see dash base. That means just pre-trained model. And then you will have versions which are model name dash instruct. That means instruction fine-tuning. And then very soon we are going to also learn about the alignment stage, and that version will be called dash check. These days, very infrequently people release instruct without version. They just release check version that we are gonna, as I said, learn about soon. So less and less you will see instruct, or they are going to refer instruct to mean this stage and the next stage I'm going to talk about. So you just need to be a little bit cautious what is instruct or chat versions of the model actually refer to, but base always just pre-trained model. So you take the pre-trained model, refine it using a data set of pairs of instructions or prompts such as summarize, answer, give me 5 books, whatever it is, with the desired response. And the idea here is that by seeing this, how to respond to instruction, the model will first of all learn how to address the instruction. It's going to also learn how to structure response in a certain style. As always, fine-tuning means you change your weights such that you minimize the log probability of data, meaning log probability of desired response given instruction or a product. And desired response is going to be many tokens long, so this is a product of individual tokens of the desired response. Now, the data itself needs to cover bunch of capabilities from reasoning, creativity, factual knowledge, coding, right? Because as you mentioned, we want an LLM to do everything for us. So instruction fine-tuning data itself has to be really broad. And if you mix it properly, maybe that forgetting problem won't be so severe. It has to cover multiple domains and tasks, so not summarization of just news, summarization of medical, clinical notes, and all sorts of things. You want to have difficulty levels, right? You want model to do easy task and hard task. And this is the first time we are also going to start to include this multi-turn conversation. So you can imagine we are playing like a Wizard of Oz situation where I'm pretending that I'm an LLM. I'm actually recruited to do the annotation of the data. And some other person that is simulating the user is asking me questions. And we go back and forth. Eventually, we mark that I'm an assistant. I'm not, but we mark it for the model. And it learns how to respond in the context of multiple terms. So that's going to happen in this stage too. Now, SFT data will, this kind of is connected to what I just said, that we're going to have this multi-turns, but we are going to structure our data in this chat format. So in my code that I have given you in a column, maybe if you remember, I had prompt, and prompt was a string, and I given this, I tokenized this string, and I given it to the mod. Here, you're going to use this chat format. It's going to be a list of dictionaries, and each dictionary will have two important keys. One is role, the other is content. Role is going to be either system, user, or assistant, and content will be content of the message. So here, system prompt is something that at the highest level, we always want the conversation to be in the context of that system prompt. So typically, you would give something to a model that's relevant for every single response it's going to give us. And as I said, we don't know what system prompts of OpenAI, Claude, and other proprietary models are. And then the first conversations with chatbots always start from the user. So we are going to have user utterance first, such as here, what is the capital of France? And then as our chatbot responds something, the capital of France is Paris. And we are going to record this as a type of message with the role assistant. And we are just going to, extend this list as conversations come. So now what happens with all of that? I will show you what happens with GPT-4o as a screenshot from TikTokenizer. TikTokenizer is their demo for seeing how GPT tokenizes text, which is so surprising that they give us, but hey, I won't complain. So I placed exact same example I have given you on the slide, like your useful assistant, what is the capital of France, and so on. What you can see is that although we give it as a list of dictionary, what is produced is a single string. It's a single string where each one of the messages is wrapped in special tokens. For ChatGPT, like models, for GPT-4o, every message is going to be wrapped in I am _ start and end. They don't have special markers for whether you're a user or assistant. Some others will have, as I will show you. Oh, I apologize. Actually, there are. Here it's user and assistant, right? Sorry. Yeah. They indicate what is user, what is assistant. What is important for you to recognize here? When you're coding this, you're going to produce this list of dictionaries with role and content keys. What is actually then happening with that, and you won't write this yourself, you're going to use the library, a string is going to be produced, and these special types of messages will be separated by the special tag that indicate this is a user, this is assistance message. But remember, input to an LLM is always a single string, right? Just because we have that list of dictionaries doesn't mean that now we are doing something weird, right? And if we now had new user message, it would just extend this same string. And the new assistant utterance, we just extend the string and refeed it to the model. And then you can again see how the tokenization has this special I'm start, I'm separator, system, user. They're all special tokens in the vocab. You have always option to add something to your vocab before you start training. And I want to finish with saying that not every language model chooses the same schema for what is the separator. So it doesn't matter which language models I use here, but some will have this special S token, then instance, then end of instance, then end of S, and so on. Some have just system, user, assistant, and here we have something we have seen with GPT-4. So there is different schema, but you don't need to worry at all what your language model was, with which schema it pre-trained with when you're using Hugging Face. So here you load a tokenizer from your language model. Here, this demonstration uses Mistral. You create your chat or messages list where, again, you have list of dictionaries which have role and content. And then you use function from Hugging Face, tokenizer.apply chat template to this chat. And it's going to create this string. So I had no idea what Mistral is using to separate users and assistants messages. And I will never need to, because Hugging Face is going to take care of that for me. And it's going to place right tags, and my input to my model is going to be proper. Okay, so remember chat format, but Hugging Face takes care a lot of that for you, but you are going to write a lot of these dictionaries. That's going to be your job. Okay, let's stop here. We have more to say about instruction fine-tuning on Wednesday, and then we are gonna jump into alignment.